what do you mean by threshold? Minimum kinetic energy needed to initiate a reaction. K minimum, what we said, that only we'll call threshold. I think I will change the K minimum, no? So this is what KTH, I wrote it. Threshold energy it is called as. Okay, fine. So since in atomic physics we call minimum kinetic energy, but here we'll call it threshold kinetic energy. So everywhere this one only, threshold kinetic energy it is. No, straight away recollect what just earlier we studied. So there's a neutron, carbon 12, and beryllium, and this alpha particle. This much is what we have information. Find the kinetic energy of alpha particle outgoing at right angles to the incoming neutron's direction. What actually happening here? Carbon, it is at rest. Proton, which is incident with certain kinetic energy. After collision, going at right angle. So this must be alpha particle, no? And this should be the beryllium nucleus. I think I'll write KB, that'll be enough. Okay, KB will write it. Or K1, K2. It'll be much easier for us. We don't know Q, no? I think if I have Q, I can do something. But if telling whose threshold initiates, activates, I think the word itself says the Q is negative for that. But the incident particle, how much it is coming? Kp is equal to how much according to the given data? 10 megaelectron volt. Agreed? The incident particle in fact coming with 10 megaelectron, which is greater than the minimum required threshold. Here, what we should call this is minimum energy of incident particle to activate reaction. There's the meaning of that. Okay, now what shall we do here? How to proceed with this particular problem? So here, so what is the equation? The main equation is this one, no? Kp plus Q is equal to K1 plus K2. So what are unknown things? K1, K2, theta. So there's the one equation, I'll keep it in hand. Kp we know. What is Kp? 10 megaelectron volt. What is the minimum threshold? The threshold is how much? Threshold kinetic energy. So this is threshold energy better you call. So now we know Kp and threshold. So let's, what is the definition for threshold? You can write it. K threshold or E threshold or K minimum. I'm using all the symbols. This should be mod of Q. 1 plus mass of incident particle. What is incident particle? Proton. What is the target nucleus? The carbon. So now we know this, how much? 6.17 megaelectron volt, mod of Q, 1 plus. How many? 12 will be there. So what is the mod of Q? This will be 6.17 into 12 by 13 mega electron volt. This is the value of Q. It is a negative. Don't substitute positive here in the equation 1. Okay, got this? So from this is one equation 2. You have to substitute negative here. I'm making things clear. Mass of proton equal to mass of neutron. Take it for granted. Okay, agree this. So like this will get it. So there's the value of Q. So if you're interested, better put sign. If you're not getting, if you're very good information, means I can put sign also, but kinetic energy should not be negative, no? That's why I'm trying to avoid sign. Here Q, you should substitute with sign. Anybody value?
5.69.
695 megaelectron. There's a mod of Q. So what is the equation now? Kp plus Q is equal to K1 plus K2. Here in this equation, Kp is how much given? 10 megaelectron volt. Q is what? Right, minus sign. I hope, I think everyone is able to understand, because the condition is given such that Q is negative. In fact, the question itself is given Q is negative. Now, how many unknowns are there? How many unknowns are there? I will call this is the equation 1. We'll proceed like this. This is the equation 2. I need one more equation. Conservation of linear momentum along x, along y. Already, I think you are very familiar. Applying conservation of linear momentum. Mass of 2m2, I'll write it. K2 cos theta along y-axis 0 is equal to m2 is mass of beryllium, m1 is mass of alpha particle. Directly has given number of nucleons, no, 9 times. So what is this should be equal to 9 times mass of proton. In terms of proton, we'll discuss the total problem. And what is m1? Substitute and solve, you'll get the required answer.
We will need one more data now, sir.
What is one more data? Why one more data? Square and add sin theta will get eliminated. No?
Okay, sure.
Anybody answer?
2.211.
2.211. I'll write it here. No space. Answer I'll write it here. Kinetic energy of alpha particle
211.
211. And this is your answer. Cross check later on. We take the next one here.